Good evening, class. Today we are going to continue with the physics on a simple machine. So to start with, I'm going to define what a simple machine is. So simple machine, this is a device that usually makes our works easy, or this is a device that is used to overcome load through effort. So now in my definition, I've used two terms, load and effort. So without wasting much of your time, I'm going to define what effort is and what load is. So effort, this is the force that usually comes from the experimenter or from the person. Then load, this is the force overcome by effort, and you can only find this force to the object you are trying to lift. Let me show you. So as you can see on this diagram, load is labeled to the lock, then effort is labeled to the person. So this is how you can identify load and the effort. So upon knowing how to identify load and effort, you should know now the types of simple machine. So types of simple machine, we have simple machine that are under rivers. We have simple machine under pulleys. We have simple machine under gears. We have simple machine under inclined plane. Now simple machine under rivers is where you can find wheelbarrow, scissors, slasher, shovel, bowl, opener, oil, and the cooking stick. Under pulley system, you can find single fixed pulley and the single moving pulley. Under gear, we only have one. Then under inclined plane, we only have one. So as we progress, I shall dig down or to bring more concept on each and every example I've mentioned here. How you can calculate, how you can find mechanical advantage on each example, how you can find velocity ratio, how you can calculate efficiency. So now mechanical advantage. Mechanical advantage, this is the ratio of the load to the effort, which is calculated by load over effort. So mechanical advantage is calculated by F load over F effort. Now what you should put into consideration is that whenever you are calculating efficiency, whenever you are calculating mechanical advantage, since it is a ratio, it should not have units. The units, they cancel each other. As you can see there, load is measured in Newton, effort is measured in Newton. So Newton will cancel, which means mechanical advantage will have no unit. We go to velocity ratio. Velocity ratio of a machine is defined as the ratio of the distance moved by effort to the distance moved by the load in the same time. As you can see on the formula there, VRR is equal to distance moved by effort, which is denoted by DE, over distance moved by load in the same time, denoted by DL. Like I said on mechanical advantage, this is also a ratio, so it should not have units. It is very important to put that in your mind as you are doing calculations. From there, we should go to efficiency. Efficiency, I know you have prerequisite knowledge on efficiency because on the previous topic we talked about this one when we were concluding on work, power and energy. So just to remind you, efficiency of a machine is defined as the ratio of the useful work done by the machine to the total work put into the machine. So the formula for efficiency, so this is the formula. Efficiency is equal to mechanical advantage over velocity ratio times 100%. So now there are critical questions they can ask you during the exam. They can ask you to explain why efficiency cannot be 100% and why efficiency is not more than 100%. So the reason why efficiency cannot be 100% is because of friction. Because during the experiment, you find that some of the energy will be lost through friction. That's the main reason why efficiency cannot be 100%. If there are questions, you are free to ask. As for today, we are going to end here. We shall continue with examples when we meet. Thank you.